So, welcome back to the coding part of this video. After we've put our devices in the allocated port, the device, the buzzer, and potentiometer, now we can do the actual coding to tell the chip what to do. At the top here, you have send to core chart, this icon here. Now if you click it, and click it once, because if you click it twice or more than twice, it's going to open up multiple of these, and then it might be annoying for you, so yeah. Now here's the buzzer 1 test. This will test to see if you put your buzzer in correctly. Now if it buzzes, that means it will work. So what we have to do is we get our data cable that I told you about earlier and plug it into our laptop. Now once it's in our laptop, we also have to plug it into the chip. Now if I plug it straight away into the chip, it's actually not going to work. Right now it's just going to run whatever code it has on the chip by default, or whatever someone else has put onto the chip. So if you want it to run what you want it to do, you have to program it first. Now in order to do that, you have to hold the button that is on the chip, the button right there, unplug the cable if you plugged it in when I didn't tell you to, and if you plug it back in with the button held, so you have to plug it in when the button is pressed. Then the device, the microchip, won't actually run the code that is already on it, but instead listen to what you want it to do. So now when you click send the program to chip, you should come up with this. Now this is just a warning to say ensure that the push button is held to make sure that the chip is in bootloader mode, meaning you can program it. So then now you will need to save it. If you named it musical buzzer, then you just go here, find musical buzzer, and name it musical buzzer. Now if you do this, it's actually incorrect, because when you do the code, there's no space, apostrophe, or any symbols. So if you want a space, you have to use an underscore like that. And then if you click save, then it's saved. And it should send the program to chip, come up with all that stuff. And then it would say programming was successful. Now if yours didn't do all of that, just click send program to chip again. And if it comes up with an error, try unplugging and then replugging the chip. So now with that part done, test to see if your buzzer actually works by unplugging and then replugging the cable back in. And it should come up with that for 1 second. I'll do it again. Like that. Now, you can either use the cable to power the chip, because the data cable is used as a programming cable and a power cord. But there are also batteries available for the board which you can plug in here in order to power them with batteries. Now, what we want to do is delete the buzzer test, like so. And then click yes for both of those. Now, if we go to outputs, we have on-off pin. If we do this, we can click on the arrows to insert the on-off pins. So with those two on-off pins, you can either turn the buzzer on and then turn the buzzer off, like so. Now, we're going to program it to play a tone, a note. So what we're going to do is we're going to get time delay and then add it after the on-off pin. The time delay will be 15 10,000ths. That will be the period of on, which is where the sound wave reaches the top, and then 15 10,000ths for it to be off, which is when the buzzer will reach the dip of the sound wave. Now if we do a go to start, it will repeat this and repeat the same tone. So now ensure that when you plug the cable in, press the button or it will play the buzzer test again, and then click send program to chip. Should come up with programming was successful. Now if you unplug the data cable and then replug it back in, it should create something that sounds remotely close to this. Now that's the first step into getting your musical buzzer working. Now the other thing is, musical instruments usually play more than just one tone. Well, I mean, each instrument's had its own way. For example, the piano has lots of different keys, but we don't have that many buzzers in our kit, so we can't really do that. But we can change it using our potentiometer. Now, how we do that is, first of all, we can delete all of this, Actually, no, keep it there. And we'll just add on to it. So now if we go here to inputs, there's something called an analog in. Put that at the beginning, double click on it, and then use the pot, the potentiometer. We'll save this as period. Now what we do with that is we go to numbers and click divide and put it after the pot. Now if we go here, double click on divide, we divide period by 25 and then save result as period. The reason we do this is because the potentiometer is a voltage driver, which means it controls the voltage, as I explained before. Now it also converts, the microchip can convert the voltage into a number between 0 and 255. Now if we divide 255 by 25, then we can get something in between 10,000th of a second, resulting in that we put the period, what we divided it by and saved it as, into the time delay, 10,000ths as period. You can click the arrow here and then select period in the drop down and do it for both. Now we have the basic fundamentals of changing our pitch. So now, same procedure. Ensure that the button is pressed as you plug in the data cable. Click send program to chip. It'll do this again and should say programming was successful. Now when you unplug it and replug it back in, the buzzer should start playing a tone. And if you slide your potentiometer, you can tell that the pitch of the buzzer is actually changing as we change the potentiometer. If you want to notice this difference more, move your potentiometer slowly instead of swinging it across. Now that is the basics for the musical buzzer project. You can extend yourself more by trying to create your own music. For example, figuring out the frequency of each note. For example, the note A is 440 Hz, meaning it vibrates 440 times. So, in order to get the note A, you go to divide, well not divide, you go to the time delay and set the 10,000ths as 11. Because since the note A vibrates 440 times, that means each wave is roughly 0.00027 of a second, or 23 10,000ths. Now, because of the design of the buzzer, we only need to do it for 11 10,000ths. So you go to time delay, double click and change the 10,000ths to 11, then you should have something remotely close to the note A. Now, if you search different frequencies and then divide them, you can figure out how many 10,000ths each note is. And then with that, you can figure out how to create your own musical buzzer. Thank you so much for making it to the end of this video. Hope you enjoyed it, and I wish to see you in other videos. Maybe subscribe if you want to, I would appreciate it. And I'll see you later.